All right, guys. So I created this little graphic chart thing here. Wanted to do it super nice and digital, but I didn't have time, so I just did it by hand real fast, just to help you put all the ideas that we've been learning together, so you can understand how it's all connected, and hopefully this will help out. So I'm going to walk you through several of these things here, and you can add to this graphic or take notes, whatever you'd like to do. So first, let's talk about outdoor air pollution. So a lot of our outdoor air pollution, as far as anthropogenic sources are related to, come from fossil fuel plants or combustion, especially coal power plants, okay? But also fossil fuel combustion from like car exhaust pipes and industry and things like that. So one of the big culprits are the SOxes, or SOx, mainly SO2, okay, from power plants, because they lead to acid rain. Now, I want to help you differentiate between acid rain and ocean acidification, okay? So just as a quick refresher here. So acid rain is when you have SOx's, or the SOx's, and the NOx's reacting with water through a series of reactions, and then you're getting sulfuric acid in the rain or nitric acid in the rain. Okay, and then that causes all kinds of problems. For example, the soil, if it can't buffer or neutralize that acid, it ends up getting like too much aluminum in the soil and other metals. It burns or hurts plants. It drops the pH of rivers and streams and lakes outside of the pH range of a lot of organisms that live in those streams and lakes. It dissolves limestone structures, so like in buildings and marble statues and things like that. Okay, ocean acidification. And going back to acid rain, anything in nature that has some sort of carbonate ion will neutralize the acid, because carbonate is a base in itself. So for example, like marble or limestone statues, what they do is when there's a drop of acid rain that falls on the statue, it actually reacts with it and neutralizes it. But by reacting with it, that limestone statue kind of starts decaying, so to speak, or it looks like it's decaying. But any carbonate that naturally exists in the soil or in streams or things like that will neutralize the acid rain. And when we're talking about ocean acidification, what we're talking about is like too much CO2 in the water that's been dissolved just from too much CO2 in the air with water makes carbonic acid. Okay, now carbonic acid, and we've talked about this before, naturally breaks up into hydrogen ion and bicarbonate. And then this hydrogen ion here is going to bind to 3 free-floating carbonates, right, in the water, and make some more bicarbonate. And the problem with this is that your shell organisms that use carbonates to make their shells, well, there isn't carbonate left over. But essentially here, what's happening is we make acid in the ocean, and then this guy here really is neutralizing the acid. That H plus is what makes things acidic. But as it neutralizes that acid, we're running out of the carbonate in the ocean, right? And that's bad for the organisms, okay? So these are similar things, but they're not the same. I want to make sure that you can differentiate these two things. Acid rain, we're talking about sulfuric acid, nitric acid, okay, can be neutralized by carbonates in soils and water, whatever. Ocean acidification, we're talking about carbonic acid, okay? That's a process that happens in the ocean. So keep those things separate in your mind. Make sure you understand one or the other. The carbonate there is a similarity, but that doesn't mean that they're both the same, okay, because they're not. All right, now coming back. So coal plants make lots of SO2s, or SOxes, which lead to acid rain. The SOxes are your main culprit for acid rain. The NOxes too, but mainly the SOxes. Okay, they also make particulate matter. So things that are smaller than 10 microns or are less than 2.5, okay? Those causes lung diseases, irritation in mucous membranes, eyes, things like that. They make carbon monoxide. I'm going to post a separate little short video on carbon monoxide. Carbon monoxide is very bad because it messes up with our hemoglobin. It doesn't. If we breathe in carbon monoxide, we actually breathe in less oxygen. So it's like a chemical asphyxiation. Okay, and it's particularly concerning indoors. Okay, and then these fossil fuel plants and gasoline combustion, things like that, can release lead and mercury in the air. Okay, so lead has been very well regulated by the Clean Air Act, so much that this is probably the most successful, or one of the most successful examples of environmental regulation that were effective in the United States. When you go get gas in the gas station, it usually says unleaded gas. I don't know if you ever thought about it, but that's actual lead, PB. There's no PB in that gasoline, so it can't evaporate because, as you know, gasoline smells real strong, right? You can tell that it's evaporating. And lead is very bad for the nervous system, okay, of the human body. So if you are consuming lead, especially breathing in lead, you're gonna get some sort of neurological damage, okay? And since we have banned lead from gasolines in the United States, kids' IQs have gone up, okay? Like the average has gone up 3 points. So it's a pretty big deal. Mercury from coal plants can go into the air, and then it can, be washed down in rain. And then it goes into the watershed, and then that's the issue of biomagnification. Okay, right? So your plankton will consume it, and then the fish, and then we eat the fish. So a lot of, for example, pregnant women are usually routinely told to minimize or cut out fish from their diets altogether, because a lot of fish that we eat does have mercury in it. So it bioaccumulates, and there's biomagnification through the food chain or the food web. So that's how all of that's connected back to stuff we talked about in the beginning of the year. This type of combustion also makes hydrocarbons, which are your VOCs, or volatile organic carbon molecules. Volatile means it goes into the gas phase very quickly, okay? So that, combined with the NOxes that come out of car exhaust pipes and light, can make ozone, okay? And that's called photochemical smog, okay? The formation of ozone in the troposphere, which is the sphere that we live in of the atmosphere, where we breathe and live in. Ozone down here, ground level ozone, or ozone in the troposphere, is bad for us. It irritates lungs and mucous membranes. It can burn slowly, of course, leaves and decrease photosynthesis, and can cause damage to tires. So it's no good. Okay, you can also, why would I put VOC here for gasoline making VOC? Gasoline evaporates very quickly, as you can probably smell in a gas station. You can smell the gasoline, right? So even before you combust it, over here on the left hand, I have it as combustion, gasoline will evaporate, and that's considered a VOC, a volatile organic compound, or carbon compound, because it is a carbon-based molecule. These are called hydrocarbons, are VOCs. Not all VOCs are hydrocarbons, but the hydrocarbons that we're talking about here tend to be VOCs, okay? So one thing I want to show you here, what happens in a lot of cities, okay? So a place like LA that has a ton of smog, okay? You get your NOxes increasing here as people go to work. So see your NO2 here, and your NOs as people start going to work, 5, 6, 7, 8 in the morning, they go up, okay? Your aldehydes here, your hydrocarbons, these are your hydrocarbons, or your VOCs, okay? They go up too when people go to work because of all those cars driving, right? Well, once you have your NOxes and your VOCs mixed with sunlight, right? So we get the most sunlight at noon here, what you're going to get is your NOxes and your VOCs, they're going to start dropping because they're going to react with each other and end up precipitating the formation of ozone. So this oxidant here is the ozone. Okay, so you need to be familiar with this graph. So your primary pollutants, the ones that we as human beings are putting into the atmosphere as we drive to work, are your NOxes and your VOCs. They tend to go up in the morning when people are starting to go to work. But then when the sun really comes, there's sunlight, there's heat, then they tend to drop. One, because people are at work, aren't driving as much, but then you also make the ozone layer here. And then as the sun starts to decrease, it actually causes everything to go down, okay? Everything to go down because the sunlight isn't there. So the energy from the sun helps the formation of this stuff. And it's present, keeps its presence in the atmosphere. So over here with ozone, this curve here for ozone tends to be lower in the winter because there's less sun and less heat, and higher in the summer. Okay, so just familiarize yourself with the general pattern, okay, of this graph. All right, so natural sources of outdoor pollution. Okay, we have trees, for example, they make VOCs naturally. A volcano could make lots of particulate matter, lots of CO2, even some carbon monoxide. Okay, so there are natural sources of pollution too. Every now and then there's a big gust of wind that takes sand from the Sahara and blows it all the way across the Atlantic. Okay, that's particulate matter. That's the PM right there. That's called air pollution, but that's a natural source. A couple more things here to wrap up our outdoor pollution real quick. CFCs, they deplete ozone in the stratosphere. CFC, remember, chlorofluorocarbons, they're super most powerful greenhouse gas. Okay, so they're bad in many ways. Those chlorine atoms from the CFC break down the ozone, and then that exposes us to UV radiation, which is bad for our skin. There's also something called noise pollution, which we haven't talked much about, but it's a very minor topic. Just noise, okay, that cars, construction, all kinds of things make, okay, that can affect the echolocation of organisms, like bats or organisms in the ocean, depending on the type of noise pollution. It can affect the behavior of organisms, also human beings, like it can add stress, irritability to human beings. It can cause hearing loss, okay, so noise pollution is also considered air pollution. Now, a couple of things to mitigate this, and we'll talk more as well here in the next video about indoor pollution. But industrial scrubbers, okay, so those are put in factories to reduce the amount of SO2. Electrostatic precipitators, okay, basically these are things that use electricity to precipitate the particulate matter out of the air that's coming out of those, so to speak, exhaust pipes of the industry, but the smokestacks basically, okay? And catalytic converters. So these are present in all cars, at least in the United States, in exhaust pipes to diminish or eliminate carbon monoxide, hydrocarbons, and NOxes. Okay, so you need to know those three terms and what they do.